here we're going to go through some of the more difficult questions from chapter 7. And we're going to start with this question 3 from exercise 7F. Now you can see already that there's a red circle around the answer here, and I'll get to why that is in a second, but let's look at the question first. It's a very general question about compound interest and regular payments. And we saw in one of the previous videos how we can use the finance function on the GDC, so coming down to this part here to work that out. Need to choose the compound interest function there. We're pretty much always going to use that one actually, and we're then presented with these variables here. So in this question, it's just a case of accurately entering that onto the calculator. So she's investing in a pension for 25 years. First confusion is that you might think n is 25. It's not, unfortunately. On the standard formula for compound interest, n does represent years, but on this calculator, on this function, n represents the number of times that interest is paid. And you'll see we've also got interest being compounded monthly here, which means that actually the number of units of interest that are being received is 25 per year, so therefore it's 25 lots of 12. And the calculator will work it out as 300 for you straight away. So that's actually 300. Next bit's more obvious. Interest rate is 8%. Yeah, 8% there. So that's just going to be 8. Remember, it's not a decimal in this particular function, it's actually percent. And then we've got this monthly deposit of 1,000 Turkish lira. Now that's going to be using the periodic money transfer function here. The confusing part here, as I mentioned in that previous video, is the signs negative and positive. Now we're going to interpret this as she is giving away 1,000 lira per month. So I'm actually going to put that in as negative 1,000. Doesn't really matter if you put that in as positive. It just means that the future value that we're calculating here, that will come out as negative if this is positive, and vice versa. So this is actually going to come out as positive for us because that's what she ends up with in the end. So these two are just going to be opposite whatever's happening. You can interpret it using common sense when you see the number. Obviously, she's not going to end up losing hundreds of thousands of lira at the end of this. Present value there is 0 because she's got nothing to begin with. I pressed the FV button by accident there, so just ignore that number for now. Periods per year is 12. That P to the Y refers to the PMT. How many times per year is this being paid? So it's being paid 12 times a year monthly. And the compounding unit is very important here. That's 12. That means that we're getting that interest 12 times a year. So this is how we set it up. Now, what we're looking for is the future value. So normally that would be at 0 because we don't know that yet. I pressed the button by accident. But then when we're looking for that, we would then press the FV and it will give us this, which you've already seen. So 951,026 lira, and then looks like 39 cents as well. Now that's not the answer that's given here. This is wrong. This textbook is pretty good, but I've noticed at least 5 errors per chapter so far in the questions, and it's because it's the first edition. This is actually quite common for maths textbooks, believe it or not, and it's a frustration we can't really do anything about because we've got just one textbook and we'll have to use this one for the time being. But you can see in the actual book itself, this is from the online version, the actual book itself does have that answer there. So 951026 is the right answer, and the textbook, the physical textbook, does have that in here, which is good. The next question is asking, why is it if she stops paying in at this point after 25 years, starts taking 1,200 out, why is it she's never going to run out of money? Well, the reason is that she's still getting interest on that amount of money. So she's got this, let's write this out actually, the correct amount is 951,026.39 lira. She's got this, she's still getting a yearly rate of 8% compounded monthly. That turns out to be more than what she's taking out. And you can work it out with the compound interest formula. So if we take this amount of money, the interest she's getting every month is going to be 8 over 100, so that's 8%, but that is the annual rate. So you would divide that by 12. And the way that would work in the formula is you would times 12 in the denominator. It's the same thing as dividing by 12. And that is going to work out how much interest you get per month. And it's more, in fact, it's this number here, it's more than this. If you try and use this number to work out the interest rate, if you put that number there and there, it doesn't give you this. But if you put this number, it does give you this. So that, I believe, is the correct answer in this case. So that's the reason. Okay, looking at the next task. So this is question 5 on exercise 7L, I believe. 7I, actually. So this is somebody who is modelling house price data. And the first thing we notice when we're asked the first question is that we're plotting the value of the house is above 7 million Czech krona in this case. So when we plot the graph, we're not going to plot 7.17. We're going to plot just 0.17 and 0.18, 0.21, and so on and so on. It's a standard practice. It just makes the graph a bit easier to read because we don't need to know they're all 7 million because they're all 7 million, so you can just ignore that for the purpose of the graph. So the graph can be pretty easily plotted on the GDC or on paper. I think I've actually got this one already on here. So I've put the numbers in here already on the stat function, just like that, and you can see I've got the 0.17 and so on. Graph that using the scatter plot, and you get that kind of shape there. But in your sketch, you'd have to put the axes on, and you can see that that is what has happened in the answer there. Now, staying with this graph, we're now asked to explain why an exponential model will be suitable. Well, an exponential model has a couple of features that you need to always be aware of. The first one is that it has increasing distances between the points as it grows larger. That's the whole point of exponential growth. It gets bigger and bigger by larger and larger amounts. And this is real world data, so it's kind of happening. It's not very, very clear, but if we look at the beginning, we've got 0.01 difference, 0.03 difference there, 0.01 difference. So relatively small differences at the beginning. The last three here, well, 0.03, 0.06 and 0.08, the differences seem to be increasing towards the end. It's not a completely perfect scale, and you can see there's a lot of wobbling here, but it does seem like it's about to shoot up like that. So the increasing set of points with increasing differences is a good reason that an exponential model could be possible here. It also seems to be flattening out at this point here, where the value would equal 0. That does make sense, but it wouldn't be absolutely guaranteed because remember 0 actually represents 7 million kroner, so it could dip below that in reality. When you're actually doing modelling, you have to take that into account, but it's a good start because it looks like it might have an asymptote there, so you can also mention that. You have to determine the best fit exponential model. So I put the data in already, as you've seen. Once the data is in, using the stat function there, we're now going to do a calculation. We're going to calculate a regression, which means a model that's going to get as close to the point as possible. Lots of options to choose from, but we've been asked to do exponential, so we're going to go across and we're going to choose exponential here. There's two types of exponential model, one that has E in it and one that doesn't. Both are actually perfectly good in this case, but we're looking for this one here on the right-hand side. Both would be acceptable models if you were giving them in an exam, so don't worry about choosing which one. But in the answers in the book, they've chosen this particular model here, and that's it. So in the answer given, they've rounded things a little bit, but we could do ours with a bit more accuracy here. So y equals a times b to the power of x. So if we were going to write that in here, we would go for, well, the y, have we got values for this yet? So the value v, so that's our y, essentially, is going to be that. And a on here is 0.1497. So let's actually round up a little bit because it's quite a tricky number, isn't it? So 0.1, I guess 150 is the best we can do there. So that's the a. That's going to be times b, which is another constant, and that looks like it's going to be about 1.10 or 1.1 to the power of x, which is our variable. But actually it's not x, is it? It's t. So yeah, that's our model. That's just come straight off the calculator there. And they've got the same thing. They put a bracket around that there, but that doesn't really achieve anything particularly. We're then asked to report the R squared number, so the coefficient of determination. Remember, this is just a measure of how far away the points on the model are from the actual points in the data, and you want that to be as close to 1 as possible. And it is really close, actually. In fact, it's 0.9851, and they've just got 985 there. So that's a pretty good model. Last bit, he wants to sell his house when the price reaches 9 million kroner. So we've got this model for the price of the houses. Basically, when is this going to hit 9 million? Well, actually, not 9 million, because we're modeling against the values when 7's been subtracted. So we actually want to know when that's going to be 2. Because when that's 2, we're 2 above the baseline of 7, we're at 9. So a quick way of doing this on the calculator, which is a bit fiddly, but it definitely is quicker than copying everything out, is to copy from here, press copy, then it will take you to the graph screen and press the equals button there. Actually, I think I've got to delete this first. See what I mean about it being fiddly. We delete the... Can we do that? Let's just try and copy into there. Okay, fine. So, look at that. Yeah, I think it actually has copied that into there. Anyway, sometimes you have to maybe copy into a blank function, or maybe just be a bit more attentive when it has copied things in. But that function with that really long number, that is actually the function we just had. It's 0.149. It goes on for a while. We round it off to 150, but it's in there now. Now, we don't actually want it in there. We just want it on the clipboard of the calculator, because what we're actually going to do is copy it into the equation solver. So the solver there, and the paste isn't paste, but it's this RCL, recall calculator memory, and we're going to pick the right one. So I think either one of those is fine, isn't it? So let's just pick that one there. And that's been copied into the equation solver now. And that's great, because we can now set that equal to 2 shift dot equals 2. It's just now going to tell us what the value of x is, and x is actually t, when we get a v or y value of 2. So we're going to press enter there, we're going to solve, and it looks like 26.69 is the answer there. 26.69. So it's actually asking how long will you need to wait until this house sells, and this is all the months here. So it looks like he's going to have to wait from the beginning here. It's not actually very clear, is it, when he's starting his waiting process, but assuming it's from the first here, he's going to have to wait 27 months. Now it says 28 months in here. That could be because of some rounding involved here. Now, in an exam, if you haven't rounded and you've kept the accurate values, that's obviously going to be better. Let's just double check this. No, I've not made a mistake here, but let's just put the rounded numbers in here. You can see how big that number is. Don't blame somebody for using the rounded value, but let's just double check that's actually what's going on with their answer. So they've probably used this rounded function here. So we just solve that. Yeah, you can see there. So that's come out as 27.177. So you'd have to wait to the 28th month. That's where their answers come from. But don't worry, in the exam, they have a range of values that they're happy with. And if it was very important that you round, it would say that. So if you got that answer, that's actually better, I think, than the one that's given there. But